This is a software engineering and design class. This is class about testing. For testing class, we have been discussed about the basic thing about testing and something about the code coverage with some methodology to using coverage. Okay, so testing is the most popular quality improvement activity. Unit testing, integration, regression testing, acceptance testing. There are four types of testing, and there's more. Okay, so roughly testing can be classified as your two things. One is white box testing, and the other one is black box testing. White box testing is just for the developer who knows the source code, and the developer can test it more thoroughly. Okay, because she knows source code. So if there's some error found, then he can fix it. Okay, because she knows and she can handle the source code. Okay. So during the in white box testing, during the construction, that is during during the coding time, you write a routine or class and check it mentally, then review it or test it. Okay, that is a white box testing. Okay, but there's limitation of developer testing. One is developer tend to be clean test. Developer tend to test to whether the code works. Okay, rather than test for the all the way code break. Okay. The developing test tend to have an optimistic view of test coverage, typically 80%, even though average programmer believe they are achieving 90%, 95% of test coverage. Okay, but the thing is, uh, you cannot do exhaustive testing. That is, you can add sample more and more. You cannot test all the test cases. That's why developer testing is about some kind of optimistic view, and developer testing tend to be clean test. Okay, so to avoid this thing, to avoid this exhaustive testing, um, people designed testing based on code structure. Okay, that is called structure-based testing. So here is an example. Before we talk about the testing and structure testing, we have to know code coverage. What is code coverage? Code coverage means measures how much portion of source code are tested. So here is some example. Okay, here is some example here. And there's very simple example. There is a class and there is a method. Okay, and there's function code. Okay, method code here, and there's some kind of branches. Okay, conditional branch here. Okay, so very simple one. But if you want to design something to test your source code, then your test case, test sample should run all the source code. Okay, there's no missing source code. So that means your testing case should cover all the line of your source code. Okay, that is basic one. That is the minimum one. Okay, that is called the code coverage. Okay, so there's many code coverage method. One is method coverage. Method coverage means every method here uh, should be executed at least once. Okay, from your test sample. Okay, call coverage is there's function call here. All the code should be executed from your test sample. Okay, statement coverage is all the statements should be executed from your source code. Branch, path, also every branch and every part of path should be executed from your test sample. And this sample should be minimum one. If you can add more test sample, but this is minimum test sample. Okay. So here is a statement coverage example. There's some statement, there's an if else statement here. So maybe once you have designed one test sample, then the result you will see only 71%. Actually, there is 1, 2, 3, 4, 1, 2, 3, 5, I'm sorry, 1, 2, 3, 4, 5, 6, 6 line of code, and with this sample, 2 line will be missing. Okay, so your coverage will be 66%, not 71. Okay, it is 66. Okay, percent. Okay, 6%. Okay, also, so you have to add more test case sample like here. Okay, even though this sample only will cover only 85%, but together, also together, you will see all the execution, all the program statement is statement are executed. Okay, so that is a statement coverage. Okay, so by statement coverage, you can find that code. That code is a code that is not used anymore in your program. Okay, unused statement, unused branch, you can find it. If you find this kind of thing, maybe you can delete, remove this part, or you can comment out. Okay, this part, this on dead code or unused statement. Okay, one more coverage is decision and branch coverage. There's branch here. Here if else, this is branch. Okay, so one test sample only run one part of branch, so coverage will be 50. So this is not enough. So you have to add more to make 100% of branch. Okay, so that is decision branch coverage. And condition coverage is kind of thing like if this guy has only one branch. Okay, but within the branch there's two conditions: x is greater than y and a is greater than b. Okay, here is one another condition here. Okay, so without executing one type of branch, because in this statement there are two conditions, so your test it will be better if you consider all the conditions in one statement. Okay, branch statement. Okay, so in this case, because there are two conditions and each condition has true and false. Okay, so you have to design 4 test cases that is for true, false, false true, false, false. Okay, so your example will be like this, and each test sample will cover only 25, 1/4 of condition, but total by applying post sample, you achieve 100% of condition. Okay, so that is conditional property. In some next thing to generate the test sample is using cyclomatic complexity. It is about cyclomatic complexity. It measures a source code level complexity. It measures number of linearly independent paths to the program module. Actually, to measure number of paths, independent paths, calculating the number of independent paths is kind of complex. So this cyclomatic complexity cannot make exact number of paths, but it can generate roughly approximately path numbers. Okay, so to calculate the cyclomatic complexity is using number of edges, number of node, and number of node that has exit point. Here is the example here. Okay, there is some source code, and here is there's if. It's more complex, the if statement. There's else. Okay, and there's some function code like here. Okay, then from this source code we can draw some graphs like this, and look at this, the statement, and we assign some numbers from 1 to 6 for each statement here. Okay, and if else, that is kind of that can come together. So I do not give separate number of line of source code. And this node represent the source code line, okay? And this edge represents the sequence, okay? Edge is the sequence, okay, the order of statement executing, okay? So here is one, it is statement therefore number 2 is if x is greater than 0. Then because this is if, there is some branch, 2 branches like here. One is go to the next statement, number 3. The other one is goes to number 5, okay? So then if s. And there's another if inside of here, okay? Number 3, the line number 3 includes the if statement, like here. So if this condition is satisfied, then you can go to number 4, like here, okay? So, but if condition does not meet this state condition, then maybe it goes to go outside, okay? And once this statement is done, this go outside. So there is 2 exit point, edge number is 6, node number is 6. Total number will be 4. 4 is, sorry, 4 is psychometric complexity. Even though you can see here, there is the path number will be 2, 1, 2, okay? But in this case, number will be 4, so it will be a little bit different, but we can assume that this is a roughly number, so roughly measure, okay, measure number. So from this example, from this calculation, then we think we can conclude that we need 4 samples, okay? So we need 4 samples. So making 4 samples, and this sample should cover all the statement here, okay? And another testing sample creation method is data flow testing. Here is the example. Likewise, from the previous example, you have a source code, and from this source code, you can make flow graph like here, okay? So the thing is, here is 2 variables, x and y, okay? And each node is defined in number 2 and number 2, 3, 2, 4, okay? So maybe you can generate some expected value for each node, okay? For the variable x and y, okay? So your test case should be made to check the variable x, y for each node, okay? So that is our data flow testing, okay? So the thing is, and you can do exhaustive testing, it is important to select good test samples to cover the execution and environment as much as possible. So we have learned some a method that is about path analysis, that is requires source code knowledge, and from this source code you can identify branches and some condition, function code, and you can generate some graph. From this graph or from this some statement, your test case should cover all the paths, okay? So that is the path, the name path analysis came from, okay? Another method is like this: equivalent partitioning, boundary analysis, decision table, and use case. Here is the method from test sample from path analysis, and the other method is equivalence partitioning, okay? So that is simple. You have value x, y, z, and you partition x, y, z into several parts. Like a Boolean, using the Boolean to test conditions. So XYZ, for example, a partition like this, the class XYZ is greater than 0, and the class XYZ is less than or equal to 0. Okay, so you can generate 8 test cases, okay, from equivalent partitioning. Okay, that is for sample. Okay, so this equivalent partitioning, doesn't need to know the source code. Just you have requirement document and you have some basic knowledge about source code, not detail, okay? And then you can make a partition for each variable, okay? Each data, okay? Then each test sample should cover all the classes for each variable like this. In this case, you have 3 samples, okay? You have 3 samples, X, Y, Z. Okay, then there's two classes. One is the class with X, Y, Z is greater than 0. The other class is X, Y, Z is less than or equal to 0. So total sample should be 8, okay? So that is equivalent partition. You have to prepare 8 samples for equivalent partition. And maybe you can use more extended version for the equivalent partitioning. In this case, rather than you apply two classes, maybe positive one and negative one, you can make that cases for each class for nominal case, minimal, and maximal case. Okay, so each partition you prepare three samples. One represents normal cases, like for example, in this case, X, Y, Z is greater than 0 for these classes. Maybe you can select any arbitrary normal number for X, Y, Z, okay? And also you prepare minimal configuration. For in this case, maybe 1 or 2 will be minimal cases for these classes. And the other one is maximum normal configuration. In this case, this is integer. For example, if you assume that this is integer, then you can apply very large number for X, Y, Z. Okay, and also the other class in equivalent partitioning, you prepare 1 sample for each classes. But in this case, you prepare 3 samples for each class. Like X is maybe normal case minus something. Okay, Y will be normally minus something, and G will be minus something. Okay, and in this case, in minimal normal configuration, maybe minus very small number, minus maybe 1,000, 10,000, minus 20,000 or 200,000. There will be one minimal number. And maximal number will be maybe minus 1 or something, right? So in equivalent partitioning, you have data and you identify classes for each data and select a sample from each data. That is equivalent partitioning. And boundary analysis is from each classes, you select a sample for normal case, normal value for that represent the classes, and minimum value for the classes and maximum value for the classes. Okay, the reason to using boundary analysis is a typical error will come from this stage, minimal or maximum number. Okay, so your test data should be something like this. Okay, and for the minimal case, maybe you can apply this number as a even though this is greater than 0, then maybe minus 0.1, very close it. So that means the reason to name the boundary analysis is when you select test case sample, then select the number that is from boundary, the class boundary. Okay, the sample data, you select sample data from the class boundary. Okay, so that is the boundary analysis. Also, you can use decision table likewise you did in code coverage and decision coverage. Here is username, password, then you select false, true, false, true, true. Okay, and then there's the expected result. Okay, so you can use the test case sample, test decision table, and as you can see here, equivalent partitioning, boundary analysis, decision table, all of them doesn't require you to know the source code. Just only what you need to know is just kind of basic logic or just basic use cases. Okay, for example, in login screen, you don't need to know about the login thing, source code for login thing. Okay, just you know what is login screen, and you prepare sample like a true false thing. Okay, and then you can get some expected output from here. Okay, so you create a post sample for each username, password. Okay. Also, one more thing is select test from use case. You created a use case, okay? Use case is a description of a particular user of a system by actor or user. You did make a use case from previous homework, okay? So you know something about, not everything, something about the use cases. Then in this case, in use case, you remember, okay, you may remember that this kind of thing, step and extension thing, okay? So from here, you can create test sample. For example here, description action, enter name and password. This is screen, validated password, allow account access here. Okay, so your test case sample will be here. Okay, you focus on these cases and you create a test sample for these use cases. And maybe because this is about username and password, so you can use decision table for creating test sample. Okay, so that is how to use case from a test, how to create a test sample from use cases. Okay, in use case you created, the use case typically generated from the requirement document. So this use case will be created before you start coding. Okay, so but these test cases from use cases, the test case can be made before you start coding. Okay, so that means this use case, this test cases can be generated without knowing the exact source code. Okay, so this is called black box testing. Okay, and there's another testing approach. One is error casing. So list all the possible defects, then test them, attempt to produce them. That is very popular one for professional testers. Okay, usually tester engineers' goal is to find the defect. They do not want to see checking. They do not want to check the system is correct and perfect. They want to, the tester, quality engineer's goal is to find the defect from the existing system. So they know from the possible defect and they try to apply this defect, then try to produce defect. Okay, so that is error casing. Okay, another method is mutation testing. So that means randomly change source code like here, and if the result will be correct, then maybe your source code will be wrong. Okay, because you change the source code, then that means your result should be false. Okay, but even though this source code changes, but no bad result comes, then maybe this routine, your source code does not generate this kind of routine. So that means your source code may have something bad in the source code. And one more thing is fuzzy testing. Okay, just throw random data. Okay, but purely random data to make better testing. Maybe some people use more knowledge to generate random data. Okay, because it is random. Through the random data, if you're using automatical tool, then maybe that's much easier to generate test case sample. Okay, and if you this test sample, maybe if you're using random data, you can generate a bunch of test sample, but it doesn't matter if the test is run on with some automatically testing tool, then it's not a big deal. Just you run the program and program may return some result. That's it. Okay. Also, one more thing is regression testing. Regression testing is just it's about the developing version. Okay, the version is going from version 1 to version 2, 3, 4, and there's implementation function is added. Okay, if you test fully, then this part testing will be repeatedly executed. Even this part will be executed 4 times. This part of function will be tested twice. Okay, so so that is regression testing. Some part of testing is some function is added, and now a new part will be tested several times. I'm sorry. Oh, okay. I'm sorry for just mistaking. Okay, so thing is like this. Okay, I want to say again. Okay, this is function 1 that is initially implemented. Okay, and next phase, new function is added, and this function will be tested again. Okay, and this function in the next step, there's 2 existing function, and new function is added here, and this function 1 and 2 will be tested again. And at the stage version 4, and F1, 2, 3 is tested more than twice. Okay, so some part is tested again, okay, so that is called regression test. Okay, but the reason to introduce regression test is in many cases, if you run test by your hand, then if something is tested before, then you try to ignore because you have limited time and you have to go home after work. Okay, so it's very hard thing to test again with the same feature. Okay, so but if you add new module, new function, then all the functions should be tested together. Okay, because the new function will affect previous functions functionality or execution. Okay, so all the functions should be tested together with the new function. Okay, so that means all the function will be tested repeatedly again. Okay, so you have to use testing suite, automatic testing suite, that will remove the burden of testing your work. Okay, so you have to remove something. You have to use automated testing suite, and you have to try repeated testing. Okay, and there is stress testing. Yeah, it is defined as intense and thorough testing used to determine the stability of given system. Okay, so that determine breakpoint of safe using limit, and to determine how exactly system fails, to confirm the intended specification are being met, and to confirm mathematical model is accurate enough in predicting breakpoint or safe using limit. That means, for example, this example, you have tested, you are going to test a car, then typically you run typical load, but in stress testing, maybe you drive a car in very cold condition, or very hot condition, or very traffic condition. Okay, that is stress testing. If you want to test your server, then typical condition, even though typical condition, typically your server runs fine. Okay, but maybe in this case you access, maybe by using some tool, maybe 1,000 user accessing at the same time to test your server, or several user accessing or using, not several hundred user is accessing using your server for several hours. Okay, that is stress testing. So if your server is perfectly designed, then maybe your server will run okay. Even though there is 100 user is trying to access your server. Okay, but if your server has some kind of breakpoint, then server fails. Okay, server crashes if many users accessing your server at the same time. Okay, so that is about the testing for a system in harsh condition. Okay, that is called stress testing. Okay, so that is it in formal method, and some plan document perspective. Actually, testing process is defined in this standard, but I don't need to introduce this standard. It is too much, okay, I think, okay. So today I covered about the testing. Actually, we have learned about the testing for the previous classes, and we have done in code analysis, path analysis part. And today I have to say, today's class will be about equivalent partitioning and boundary analysis, decision table, and other testing methods. Okay, but roughly I discussed our previous topics about my classes. Okay, that is done, and thank you so much for listening my classes, and I hope you listen this class material and prepare your exam well. Okay, thank you.